Welcome to my YouTube channel today. I am going to be teaching you the salt analysis problem that you are likely to see on your examination. Now, remember that the WAEC 2024 specimen stated that your specimen C is stated that specimen C is a mixture of two inorganic salts. This salt is sodium carbonate and lead-2 nitrate. Sodium carbonate and lead-2 nitrate. Take note of this. These are the two salts that is in specimen C. Remember, they always call it specimen CN. N is the candidate serial number. Okay? Now, if we have this specimen to be tested for, remember that if you take this salt and this salt, you mix it together, which is labeled as specimen C, in the ratio of 1:1. If you have these two salts mixed up together as what we refer to as specimen C, what you should note is this, that these two salts will react together. And by the time they react, this is what you are going to see. Now, let's assume this one and this one, they are mixed up together in a container. They will first of all react together. Now, if you have sodium carbonate plus lead-2 trioxonitrate 5, if you mix up these two salts together, they will undergo a chemical reaction called double decomposition. What is double decomposition? Double decomposition is the process by which two reactants decomposes or react by exchanging their radicals. That is to say that the carbonate will switch to the lead, while the nitrate will switch to the sodium. Okay? So that it will become, instead of having sodium carbonate, it will become sodium nitrate. Okay, sodium nitrate. Then instead of having lead carbonate, lead nitrate, you have lead carbonate. So you have PbCO3. This is what you have. You can balance the equation, okay? Now watch this very well. That is to say, this specimen that contains this and this mixed up together will react by itself. They will react spontaneously by themselves. And by the time they react with each other, this will want to be left in the world, in the container that you are to use for your experiment. So it is no longer sodium carbonate and lead nitrate. It is now sodium nitrate and lead carbonate. This is what we now have as our new specimen specimen C. Take note of that. These are our new specimen C. And then if you analyze the nature of this salt and this salt, you will find that these two salts have their various properties, okay? For instance, remember that sodium nitrate is soluble in water. Yes, take note of that. Sodium nitrate is soluble in water. All trioxonitrate 5 are soluble in water. And then you know that your lead carbonate is insoluble in water. So that is to say, a mixture of, if you put our specimen C into water, you are likely to observe that this one will dissolve, while this one will be left undissolved. So it's going to be a mixture of a dissolved solute and undissolved solute. Why? Because specimen C is a combination of two salts, soluble and insoluble. The reason why they will have to react is because, remember, the initial specimen was this guy. And if these two guys ordinarily dissolves in water, they'll be soluble. So it will be difficult to test for the filtrate and the residue. So that is why they have to react. And by the time they react together, you have these two. This guy is soluble. This guy is insoluble. That is to say, if I dissolve specimen C in water, you will discover that some part of the specimen will dissolve, while some will be left undissolved. Now, if I have my solution, a mixture of these two in water, and then you filter with your funnel. Now let's assume this is our beaker. This is our beaker, okay? And then you have your funnel, and here happens to be your filter paper. Ladies and gentlemen, watch this. Now, if you put a mixture of these two compounds in water and then you pour into this place, remember that this guy is soluble. So you have a filtrate here. And the filtrate you have is sodium triazonitrate 5. Why? Because this guy is soluble in the water. Then what will be left here will be called the what? Residue. Okay? And this residue is what? Lead carbonate. Now, so that is to say, our filtrate is what? Sodium nitrate. While our residue is what? Lead carbonate. That's what we have. So whenever you are testing for residue, you should know, you have at the back of your mind what you have there. And we are testing for filtrate, you should know that you have sodium what? Nitrate. And then we are going to take, you know, the general procedure for carrying out your salt analysis is that you have 3 columns, one for test, one for observation, and one for inference. Now let's quickly do that and see what will be our net result. Okay, let's do that quickly. Now watch me carefully. If I have a column here called test, I have another column called observation, and I have the next column called inference or my conclusion. Watch this carefully. Now this is our text, here is our observation, and here is our inference. Please have it at the back of your mind that our filtrate is sodium nitrate. Take note of that. Our residue is what? Lead carbonate. So with this being our residue and this being our filtrate, you have to be very careful. So let's do this part. Now, the first thing you will be likely to do is that they will ask you to dissolve what? A spatula of your mixture, okay, in 10 cm cube of water plus your word filtration. Okay, please, specimen C plus 10 cm of water plus filtration. What will be our observation? If you carry this specimen now, put on, I told you that some parts will dissolve, some parts will not dissolve. Why? Because specimen C is a mixture of a soluble and an insoluble salt. So watch carefully. If this happens to be our first test, it means that we are going to record our observation this way. Listen, you will say dissolves what? Partially. Take note of that. Dissolves partially, comma, leaving a colorless filtrate and a white residue. A white residue after filtration. Take note of that. After filtration. Wow. So if I dissolve it, I will discover that some part will dissolve. That's why I said dissolve partially, leaving a colorless filtrate. When you filter, you see that the filtrate will be colorless, okay? And the residue will be white. Remember, I told you, your residue is lead carbonate, filtrate is sodium nitrate. So what will be your inference or your conclusion? You will simply say that specimen what? Specimen C is a mixture of a soluble and an insoluble salt. Yes. So you simply tell them that it's a mixture of a soluble and an insoluble salt. Wow, that's interesting. Now remember, by the time you have your residue and your filtrates, okay, have it at the back of your mind. Filtrate is sodium nitrate. Residue is lead carbonate. Now, by the time you have your filtrate and your residue, you might be told to take your residue and divide it into different portions in a test tube, as well as your what? Filtrate, okay? But have it at the back of your mind what your residue is. Make sure you have it at your head that your residue is lead carbonate. So when they are asking you to add any compound, you should know what they are testing for, okay? If I have lead carbonate, if my residue now lead carbonate like this, they can ask you to test for lead 2 ion, or they can ask you to test for CO3 2-. So I want you to know that your residue na lead carbonate. So whenever you are told to add a compound, you should know that you are testing for either lead or what? Carbonate ion. And remember say, if you wan test for cation ion, wetin dey use to test for cation ion? There are two basic reagents used to test for any cation ion. What are the reagents? Number one na sodium hydroxide. Number two na aqueous wetin na ammonia. So if dem say make you add sodium hydroxide or aqueous ammonia, you just remember say, oh, na lead dem say make we test for, na lead dem wan check. Okay, so when you are adding sodium hydroxide or aqueous ammonia, you are testing for wetin na lead. Yes, have it at the back of your mind. Okay, now, so what do? We simply do this now. Watch this. Residue plus sodium hydroxide in drop and wetin na excess. Take note of that. Now, if you put sodium hydroxide into the residue, you know say the residue na the one dey on top of the filter paper wey you don put for another small test tube. If you put am, you will discover that it will form a white PPT. So what will be our observation is simple. We will say that white PPT. PPT means precipitate, okay, formed, which is, now you see this white PPT that is formed. If you further add sodium hydroxide in excess, just dey pour am, continue to dey pour am, you will see that the white PPT will dissolve. So we say white PPT form, which is soluble in wetin na in excess. Take note of that. And if that happens, there are three basic ions that exhibit this property. One of them na wetin na lead-2 ion, the other one na wetin na zinc ion, then you come get wetin na aluminium. So take note, you either have lead, zinc or wetin aluminium. So if this is what you have, it is quite very easy. Take note of that. I told you, when you are adding sodium hydroxide, you are testing for cation ion, and three cation ion that should be noted there is lead, zinc and what? Aluminium. So wetin you go do? You go write wetin na suspected, meaning say you never finally confirm wetin dey inside, but you are suspecting that it's likely to be lead or zinc or wetin na aluminium. Well, the next thing wey they go say make you add na aqueous ammonia in drop and in excess. Oya, make we do am now. Now, the same residue plus aqueous ammonia in drop and excess. Oya, see am. Don't forget, this one is on its own. Now, if I add aqueous ammonia to the residue, remember sodium hydroxide and aqueous ammonia is to test for cation ion, so don't think it's carbonate. Take note of that. So if I take residue now plus NH3 aqueous ammonia in drop and in excess, what will happen? The same thing will be observed. White PPT formed, which is soluble in wetin na in excess. Which ion dey exhibit these characteristics? Only two of them. One na wetin? Lead, and the other one na wetin? Aluminium. So we can say wetin na present. So we are likely to say it is either lead or wetin na aluminium. So zinc don comot now. You dey see am now. Make sure you are very careful in recording this your word observation and your word inference. Now that we have lead and aluminium, do we want to confirm the presence of lead? Because I tell una say the residue na wetin? Lead carbonate. So then I want to confirm the presence of wetin na lead. What do we use for the confirmatory test for lead? There are two basic reagents used to confirm the presence of lead-2 ion. What are the reagents? See am. The first one na wetin? Dilute HCl. If you use dilute HCl, you must put wetin they call gentle heat. That means you go heat am small. Or you go put wetin we dey call potassium dichromate, which is, okay, either you use dilute HCl or you use potassium dichromate to test for the confirmatory word presence of waiting lead. Okay, now so we are going to still test on the residue. Why? Because we never confirm fully whether na lead or na waiting aluminium. So the next one they go say me you do now either of these two. Either they say you put this one or they say you put this one. Yeah, move one quickly. Residue lead to carbonate. So you have test, you have observe, fission, and you have infer. You see post it here. Okay. 1, 2, go on. Okay, so now the confirmatory test for lead, like I told you, if you want to confirm the presence of lead, you can either use dilute ACl plus heat, take note of that, plus heat, or you will use potassium dichromate. So they can either say you should add this one or potassium dichromate, take note of that. So we'll simply say residue, we are still on the residue, plus wetiner, plus dilute what? ACl. Take note of that. If they add the ACl to the residue, what will happen? See, you must still do what they call gentle heat. I will tell you what to be observed in case they separate residue from gentle heat. Okay? Now, if you put the ACl to this residue, it will form waiting white PPT. Take note of that. White PPT formed. Then when you hit the white PPT that is formed, you hit them. What will happen? We will say disappears. On hitting, if you hit them, the PPT will disappear. But do what? Reappears on cooling. So this guy dey funny. Remember say, if you get lead 2 chloride, remember that all chloride salts are soluble in water, apart from those of lead, mercury, and wetiner, silver. But this lead 2 chloride, if you put them for water, it will not dissolve. It will form white PPT. But if you heat them, it will dissolve. If it cool, it will reappear again. So now why we say white PPT form disappears on what? Heating, but reappears on wetiner, cooling. Which chloride they exhibit this guy? Lead 2 plus confirmed. So now either way tell you say do this one, or they go say make you do wetin, make you carry the residue plus potassium wetiner dichromate. Take note of that. You either take the residue plus potassium dichromate, or you do this one. Then if you put potassium dichromate on the residue, this one will be observed. You will see that a yellow wetiner PPT is what? Formed. Take note of that. Then that's also confirmed for the presence of wetiner lead. So lead 2 ion confirmed. That is the test for lead. Now remember, on this same residue we get wetin? There are 2 ions there. We get Pb2 plus, and we get wetin CO3 2 minus. So as we don test for this guy, remember I tell una say you go use sodium hydroxide, aqueous ammonia to test for cation. This guy na anion, negative ion. So you will not use sodium hydroxide. So if they tell you say add HNO3, they will not tell you to add ACl to test for this guy, because ACl cannot dissolve the residue completely. So but HNO3 will do it. So if we say residue now, watch this abeg. Residue plus dilute wetin? HNO3. See am? Residue plus dilute HNO3. If you carry residue, put am, join HNO3, as if you add HNO3 to the residue, this is what you observe. It will dissolve completely. So we write dissolves completely, comma, effervescence occur with the what? With the release of a colorless, okay, and wetiner odorless gas. Yes, the gas that is given up is colorless and odorless. By the time you add this NO3 to the residue, it will dissolve completely. Effervescence will occur. If you check the gas will be colorless, it will be waiting and odorless. Now, by the time a gas is colorless or odorless, you begin to suspect various gases, most especially CO2. And if you suspect say na CO2, it is expedient of you to test am with lime water. So you will simply say which wetin turns lime water milky. Take note of that. So that means na only carbon dioxide dey turn lime water milky. So which ion dey there now? We go simply say CO what? CO2 gas from where na? CO3 2 what? Minus confirms. You dey see am now? Now, this is the end of the test on the wetin residue. So we go jump over to wetin we dey call the wetin filtrate, okay? The test on what now? The filtrate. Since we are done testing for the wetin residue, class, please take note of this. Watch this. See, if the filtrate na NaNO3, remember say if this guy ionize, him go give you sodium ion and wetin triazonitrate 5 ion. Abi now? Yes. Now, this guy now, sodium, the confirmatory test for sodium is zinc uranyl ethanoate. So they will not, or you do what they call flame test. So there will be flame test to confirm the presence of sodium ion, of which from the specimen given, we don't have the material required for the flame test for sodium ion. So they will not ask you to test for this. Let's remove that. So what will be left to be what? NO3. So now only NO3 minus they will ask you to test for in the filtrate. Or yeah, may we quickly do am. See, if they tell you say filtrate plus freshly prepared FeSO4. If you add freshly prepared FeSO4 on the filtrate and then you add plus concentrated H2SO4 carefully, or you pour it slightly, as in when you bend it this way, you put it by the corner, okay? So we can write carefully. Okay, so freshly prepared FeSO4 plus conc H2SO4, what will be observed? Very easy. You will see that a brown ring will be formed. Brown ring formed at what? The junction of the word two layers. Now this brown ring is due to the presence of what? NO3 what? Minus. Confirmed. So this is what we can do for the filtrate. So the one that is longer is the word residue, okay? So finally we have come to the end of today's video lesson. If today is your first time for coming across my YouTube channel, we have a lot to offer you in this channel. Please do well to subscribe to this channel. Also help us to like and then share this with your friends. Thank you very much.